स्टूडेंट बात करेंगे कुछ टीसीपी/आईपी प्रोटोकॉल सूट के बारे में। स्टूडेंट्स, ट्रांसमिशन कंट्रोल प्रोटोकॉल एंड इंटरनेट प्रोटोकॉल suite, which governs the protocol communication or the set of protocols in a layered architecture that govern today's internet. Since TCP/IP protocol is the protocol that we follow not just in this particular course, but in our computer networks course as well. The different layers that we are going to be talking about in this particular lecture will form the basis of the different areas of this course that we are going to be exploring, the different layers of the TCP/IP suite that we are going to be talking about in this particular course. Students, TCP/IP protocol suite के अंदर there are multiple layers. Protocol layering का जो concept हम लोगों ने discuss किया था, that is what is deployed in a TCP/IP protocol suite. Each layer performs a specific function. Each layer is dedicated for that function. Each layer works in a hierarchical manner. Hierarchy का क्या मतलब है इसमें? Each upper layer uses the services of its lower layers. Hierarchy is there in a TCP/IP protocol suite. Students, TCP/IP protocol suite was presented by Vint Cerf and Bob Kahn in 1973 in the form of a paper that they wrote, a research paper that they wrote. And it was refined and refined by its use in ARPANET and other networks until the 1983 part of it, when this protocol suite was made or announced as the official protocol suite of the internet. Students, slide की जानिब चलेंगे and we'll look at the layered architecture of the TCP/IP protocol suite. Students, on the left hand side, you can see the original layers of a TCP/IP protocol suite. What do I mean by that? Students, original layers are the layers that were actually presented in the initial research paper when this protocol was presented. There were only 4 layers: the application layer, the transport layer, the internet layer, the network interface layer. And below that, we assume that we have a set of hardware devices that are also included in this data communication system. Students, with further refinement of this protocol suite, we now have 5 standard agreed upon layers in a TCP/IP protocol suite that we use in today's internet. Layer number 1 is your physical layer. So mostly your hardware devices, but we have named it as the physical layer. Layer number 2 is the data link layer. Layer number 3 is your network layer. Layer number 4 is your transport layer. And layer number 5 is your application layer. And we'll talk about each one of these layers in further detail in the next discussions. Students, to understand this protocol suite better, let's take an example. Students, we are looking at a layered architecture. And in this layered architecture, we have got 3 local area networks, 3 LANs, which are connected together by using 2 link layer switches. There is also a router that connects these 2 local area networks to each other. अब students, देखिएगा कि इस scenario में, इस example में, we have got 2 hosts. We have got a source, which is represented by A, and we have got a destination, which is represented by B. We have got 2 switches. You have got a switch on the source side, and then you have got a switch on the destination side. And these 2 small local area networks are then connected together by using a router. Students, layered architecture following the TCP/IP protocol suite dictates that our 2 hosts will have all 5 layers that we have just discussed from a TCP/IP protocol suite perspective. It will have application, transport, network, data link, and physical. The switch that we call as a layer 2 device will only have 2 layers: data link and physical. the router, which we call as a layer 3 device, routing device, will have 3 layers: physical, data link, and network. Similarly, the switch on the destination side will also have 2 layers. So students, एक बड़ा apparent advantage that is very evident from this figure is that not all the devices in the network need to have all 5 layers. We can actually save cost. We can reduce complexity by having just the layers that are required in the connecting devices or in each of the devices that are making up a part of the network.